The particle moves in a straight line with acceleration 2t minus 3 ms meters per second squared at a time t seconds. At time t0, the particle has a velocity of 2 meters per second and a displacement of 1 relative to the fixed point O on a line. Okay, so there's some random point O, and then you start here and you're distance 1 away from that line, displacement 1, so 1 in the positive direction, and you have an acceleration 2t minus 3, which means you're probably going to accelerate from O, okay, because time has to be positive. Is that alright? Now, okay, the times at which the particle changes direction. What do we mean by change direction? V equals 0, usually. Okay. Now, yeah, you can do it like this, alright? So, acceleration equals what, guys? Anybody tell me?
2t minus 3.
And it also equals differentiation wise? The change of velocity over the change in time. 2t take away 3. Okay, and we can say that the v equals 2t minus 3. What do we know about the limits? What's its velocity when t equals 0? 2. And we wanted, we don't know the time, do we? What do we know though? The velocity is 0. I know the marking scheme uses v, which is fair enough, but we know the velocity is 0, don't we? So it doesn't matter if we use v or 0, it doesn't really matter, does it? What I do in this case is I'd probably read on to part 2 and go, I probably need the equation for part 2 anyway, so I might as well just leave it as v. But you could go direct with 0 if you wanted. Okay, that's your call. So I just had a quick peek at part 2 and goes, I need it anyway, so I'll just drive on here. Okay, so we're going to integrate v to v. It's going to be from v to 2, and here's going to be, what's that? T squared minus 3t. Happy days, and that is from t to 0. And then you're going to get v minus 2 equals t squared minus 3t. And then your velocity equals t squared minus 3t plus 2. Now, what type of function is this, lads? It's a quadratic U-shaped function, which means it only has one turning point, which means the velocity is negative on the way down, but the velocity will then result in being, sorry, let me think. No, give me a sec. It's a velocity time diagram. It doesn't necessarily mean, it means you decelerate, but it could all still be positive, couldn't it? Do you get what I'm saying? If it was a graph like this, all the velocities are positive, it's just that the velocity decreases and then increases. It's a different story if it goes negative and back up again. So what exactly is it looking for here? Changes direction, doesn't it? Alright, interesting. I'd have a quick, you know me, I'm very reliant on this thing, but I'd have a quick peek at this and just to explain to myself exactly what's going on with this function. I only have to be worried about what type of numbers here. Positive x's, okay? Because time can't be negative. So I'll go 0 to 25 even. And I'll just have a quick look. SAR hits 0. And then it raises forever. The velocity is never, ever, ever. It's never negative, is it? Okay?
Well, it could be negative between 1 and 2.
Could be negative between 1 and 2. Fair enough. So, what am I going to use? step of 0.5. Have a look. Range error. Alright, that means I have to reduce 25 back down to just call it 5. Yeah, we're right there, it is there. In between 1 and it goes negative and then it goes positive again. So we have our answer, don't we? What's our answer?
1 and 2.
It changes direction once. Velocity's negative once and then it's positive once. Alright. Interesting to see what the marking scheme does with this. So it solves the 2 times where it's 0, doesn't it? And as we've discovered earlier, it goes, because it has 2 roots, it means it goes negative and then goes positive. So the presence of 2 roots, A and B, so the presence of the 2 red dots means it goes negative and then it goes positive again, which is only 1. It only dips below once and then goes back up again. So when you solve your 2 turning points, t equals 1, t equals 2, when you solve it equals 0, you can say you have the full picture then, don't you? It goes negative, then comes back up again. What happened if you had only 1 turning point? As in, what happened if it touches the axis and goes back up again? What would that be? Does it ever change direction? If it touches the axis and goes back up again, does it change direction? No, that's equivalent to somebody running, stops, and then just goes forward again. The velocity never ever ever turns negative. But what we're describing here is basically somebody runs, they hit 0, then they go negative for a second, which means they go backwards, and then they end up accelerating forward again. That's what we've just done with our graph. Okay, that's the difference. And if it didn't touch the graph at all, what would happen? As in, if it had no roots, what would that mean? What happens if I couldn't solve this?
It never stops.
You never stop. You get slower, but you never stop. So you're running fast, you get slower, you're crawling, and then you go faster again. Is that right? They're the 3 different scenarios you could have with those quadratic equations. Okay? It's important you actually understand what is physically going on with that equation. Okay? Now, find an expression for the displacement of the particle from O at a time t. Alright, so that means we're going to use velocity, aren't we? So it means we're actually going to use this equation after all. So what's v again? Different way of saying v? ds dt. And I'll just skip a step here. ds equals t cubed minus 3t plus 2 dt. We all good? Now, what are the limits, do you reckon? What does it say at the beginning? You're a distance of 1 away at 0, and we want s and t, because if you reread the question, it wants the distance in terms of time. We all good? Alrighty. Now, what we're going to do next, guys, is the following. We're going to do s from s to 1. And we're going to do t cubed over 3 minus 3t squared over 2 plus 2t, and we're going from t to 0. Alright. Now, s take away 1 equals, throw in t there, so that's no big deal. It's a third t cubed minus 3t squared over 2 plus 2t. And then it would be just take away 0 for the lower limit, but we're not too concerned about that at the moment. Oh, why did that happen? Anyhow, bring the 1 over the other side and what happens? Plus 1, is that alright? So that's our equation here. This is our distance s. Right? S is displacement, not distance. So s will go up and down, won't it? It will get higher and lower. Now, what does one from next? The total, it's trying that thing again. The total distance travelled in the first 2 seconds. Now, quick cheat for you. What we could once again do, let's just have a quick look again. So 1 over 3 x cubed. We're going to use this for the limits anyway, so it's all good. What's it? 1 over 3 x cubed. Yeah, minus 3x squared over 2. Or just 1.5, I suppose would be quicker. And then plus 2x plus 1. Okay. Start at 0. What does one? Just the first 2 seconds? Just have a more closer look at it. 0.25 even. And end at 2. Right, what's actually going on here? Starts off at distance 1. It increases its distance away from the point O, doesn't it? At what point does it start to turn around? We already know this, don't we? It's t equals 1 and t equals 2. So we have to integrate that separately, won't we? We'll have to integrate that separately. And then it comes closer, back towards... Yeah. Wonder how close that answer would be, the answer we have there. So, in a way, I'd be... What's it? 11 over 6. It's a distance of 11 over 6. But you started it, so I'm technically I almost have this answer without even doing anything, right? It's 11 over 6 for t equals 1. What's t equals 0 again? T equals 0 was? 1. What's 11 over 6 take away 1? 5 over 6, okay? Then, if you start at 11 over 6, which is t equals 1, and you pause at 5/3 for t equals 2. So what's 11 over 6 take away 5/3? 1/6, is it?
Yeah.
And 5/6 plus 1/6? The answer is 1. Interesting to see if that is what it works out as. Ah, it is. And it's exactly what I just did. So, to get you formal marks here, you know the turning point is, t equals 1, s equals 1/3 1 cubed, minus 3 times 1 squared over 2, 2 times 1 plus 1. We have that marked as 11 over 6. Alright? But you have to remember that you're already a distance of 1 meter away. So it's technically 11 minus 6 minus 1, which is 5/6. Is that okay? And for t equals 2, sorry, you're going in between t equals 1 to t equals 2, aren't you? So you know that t equals 1 is 11 over 6, and then you're going to sub in your values for t2, which is 1/3 2 cubed minus 3 over 2 2 squared plus 2 times 2 plus 1. And once again, what did we get? 5/6, was it? Yeah, table function makes, 5/3. So, at the start of t1, you were 11/6 away from the point 0, and then at the end of t2, you're 5/3 away from it, which means you actually moved closer to that point, didn't you? So it means you take the two of them away from each other, and we got 1/6. So it's 11 over 6 minus 5/3, which is 1/6. Total distance travelled is the two of these added together. 5/6 plus 1/6, and that equals 1 meter. We alright with that, guys? Alright. What question is this again?